All right, in this video we're going to talk a little bit about how to predict our products when we have a double replacement reaction. And what I need you all to have from your teacher is this piece of paper right here. All right, that's what it looks like. The title of it is Solubility of Some Ionic Compounds in Water. We use this table much like you use a periodic table, much like you use your ion sheet. You use this thing when we want to predict our products in double replacement reactions. Okay? The bottom of the paper, I have for you a sample of what one would do in predicting products. All right, so this is all written out for you. There's all directions with this. You can read it on your own. What I'm going to do is I'm going to be using this top half and practice what the bottom half, oops, that's the same thing. Practice what the bottom half talks about, but with this piece of paper here where it says predicting double replacement reactions. So you're also going to need a copy of this paper. Okay? So, again, I'm going to just talk about what to do here, which is exactly what the bottom of this paper describes for you in written form. So you always have the written directions on the bottom down here to go back and look at when you need to study. So in a double replacement reaction, you've learned that you need to have two ionic compounds. If you look down this page, you'll see everything here is an ionic compound. And if you're really spotting things, you're going to notice there's a typing error because that should have had a 2 there. Because in order for a sulfate to be a sodium, you need to have 2 sodiums. Otherwise, the charges wouldn't balance. I don't know if I see any other typing errors, but that one just glared at me. All right. So in double replacement reactions, the positive ion, calcium, will separate from the negative ion, iodine, and combine with the other negative, the carbonate here, leaving the negative ion, iodine, to attach to the other positive. All right? So that means, and you can write the two products in any order. You can write the calcium product first, or you can write the sodium product first. It doesn't make a difference. You just need to make sure you write the formulas correctly. So we know that calcium is a positive 2 ion. And if it's going to go with carbonate, carbonate's a -2 ion. So it'll be written like CaCO3. All right? And sodium is a positive 1 ion. And iodine's a -1 ion. So when you have a +1 and a -1, you're just going to have one of each. Notice that the subscript 2 with these do not carry over into the formula because you have to think about the charge of each individual ion. And when they come together with new ions, what would be its new formula? Okay? So what we have to do with these things is we have to focus on the negative ion here. So this negative ion is carbonate. And we're going to go down on that piece of paper we had before and read down and try to find where carbonate is. So there's carbonate. See that? Okay, so that's the part in this paper we're going to look at. Our carbonate here is with calcium. So when we go to the carbonate, all of these things read together. So we read across. Are we with calcium? It says if carbonate is with an alkali ion or ammonium, and you guys are looking at alkali ion. Oh my gosh, what's an alkali ion? Up at the top, when I listed the alkali ions first, I put all of them with them. Notice that calcium is not part of that alkali ion list. So when we go to carbonate, calcium is not an alkali ion, and calcium is not ammonium. So we're not going to look at this line. We're going to go down to the next line, because that will apply to us, that with our carbonate, we have any other positive ion. So we read across, and it says not soluble. When something is not soluble, it means it won't dissolve. And so that means what we have is something that's a solid. Okay, we're going to do the same thing now with this one. We're going to look at the negative ion. The negative ion is called iodide. We'll go down our sheet here to try to find iodide, right? Our iodide here is with sodium. So our iodide is not any of these. So we skip that line. We go to the next one. It says any other positive ion, read across, and the word says soluble. When something is soluble, it means it will dissolve, and so that means we have an aqueous solution. All right? You know a double replacement reaction will occur if one of your products forms a solid or if one of your products is water. Double replacement reactions occur if one of your products forms a solid or if one of them is water. If you had aqueous and aqueous here, then that would be considered no reaction. All right, so now that we predicted this, the next thing you would do in your lab is you would balance the equation. All right, so you can see 1 calcium, 2 iodine. We need to put a 2 in front here. 2 sodium, we have 2 sodium, 1 carbonate, 1 carbonate. It's balanced. Okay, so I'm going to do another one with you. Okay, magnesium is +2. It's going to go with the negative ion of this compound, which is sulfate. It's -2. So we'll have MgSO4. Our copper has to be +2 if it's with sulfate, because sulfate's a -2, so this copper has to be a +2 charged copper. So the +2 charged copper will go with chlorine, and since chlorine's a -1, it's going to have to be CuCl2. All right? Notice that as I write these formulas, I'm constantly thinking of the charges of the ions to make sure the formula of our products are written so that they're electrically neutral. All right, we're going to look at sulfate. Sulfate is with a magnesium. So we go down our list. Sulfate. Sulfate is with magnesium, which is none of those. So we go to the second one, and it says soluble. Soluble means we're going to put an AQ with this. Right? Our next one is chlorine. Chlorine is with copper. So go down your list. There's our chloride. There is copper, but notice that this copper is a +1 charged copper. Our copper here is +2. It's with 2 chlorines, right? So this does not count for us because this is only a +1 charged copper. So with this chloride, we have to go with the any other positive ion, and it says soluble. All right? Soluble means aqueous. Since both of our products here are aqueous, meaning they're both dissolved in water, this really is a no reaction. This would never happen. When you mix these, you're not going to form a solid. You're not going to form anything. And when we have this no reaction, you don't worry about balancing. We're done. All right? I'll do one more. Let's see. I'm looking at the paper, and you guys are probably freaking out about number 10 because it looks so huge. So I'm going to do that one with you guys. All right. That's sodium, and that's chromate. That's lead, and that's acetate. That lead is with 2 acetates, so that lead must be a +2 charge, right? Okay, so the sodium, which is +1, is going to go with the negative acetate ion, which is -1. So the formula will be written with 1 sodium and 1 acetate, okay? Even though there's a 2 with this, that's a -1 and that's a +1, so you only put 1 of each together, okay? And that leaves the lead, which we identified as +2, attaching to the chromate, which is -2. So we'll have PbCrO4, okay? So on the product side, okay, we only focus on the product side. We want to find the acetate ion, and we see that it's with sodium. So go down the list here, find acetate. When acetate is with anything positive except for these two. So if it's with anything positive, which is our sodium, it's going to be soluble. So we're going to write AQ with this because it's soluble. Still on our product side, we're going to look up the chromate. Notice that chromate is with lead, and that lead is a +2 charge. We're going to keep that in mind. Lead is a +2 charge. So we go down our list, find chromate. Chromate with lead. There is a lead that's +2 charge right there. Read across. And it says not soluble. Not soluble means it forms a solid, a precipitate that will form. And so this reaction will occur. And now we focus on balancing it. There's 2 sodiums here, and there's 2 acetates. While we're here, we only have 1. So we put a 2 in front of that. There's 1 lead and 1 chromate, so we don't have to do anything with balancing that. All right, so when you guys do your lab, if you recognize the fact that it is a double replacement reaction, right? And you're trying to figure out your products, this is the sheet you need to use. And remember, a reaction will only continue going through if one of the two products that you have here is a solid, or if one of the two products you make is water, H2O. If you get two things that are aqueous, right, it's a no reaction. All right, hope this helped you guys out.